Okay, welcome to problem 4 of the sample final. So actually you don't have this figure over here. I got it from elsewhere. And so let's run this problem, I guess, on this figure. Okay, so let's do 4a first. We need to show an adjacency list presentation of the graph. Well, we start by listing all the nodes. So we have A, B, C, D, E, F, G, H. Okay. Let's just put B here, I guess. A, B, C, D, B, and then E, F, G, and H, V. Okay. I'm gonna zoom out a little bit. And then what do we have here? Okay, so what we do is start from A, let's say, and then we list, I suppose, let's just draw a line or something, or I guess we could also just do that. I'm not really sure. Oh yeah, I'm going to draw a line. Okay. Okay, a sad line here. Okay, that's better. Alright, so what do we do? Start from A and see where it points to. Okay, it points to B. And that's all. Okay. What about B? B points to C. Okay, and that's it. And then C points to only E. And D points to only B. And then E points to D. Okay, and let's see. F points to G. Okay, and H. Wait, no, and then G points to H. And also D. Okay, so I would rather use alphabetical order. So D, and then H. Yeah, okay, so G points to 2 nodes. Okay, and then we have H pointing to E. Okay, and then V points to 3, A, D, and F. Okay, so this one is done. Right. For part B, we need to find a DFS tree starting from vertex V using the adjacency list. Okay. So we start from B, which is over here, and we add it on the tree. Or you could just maybe draw this. Let's call this one B. Okay. So then what we do is run it and start from all vertices adjacent to V. So the only one is A. Okay, so what we do is have an edge pointing to A, and what we do next is call the algorithm on A. So I go to A and I find all edges. So by the way, I have to mark this one as visited. Okay, and now I call it on A. I mark this one as visited, and then I call it on B. So I go to B and I mark this one as visited. So I'm just gonna write viz because it's easier. And so what I would do is from A draw an edge to B. Okay, and then so from B I go to C and I call it on C. So I mark C as visited. Okay, and then from C I go to E, and then I call the algorithm here, label this as visited. So from E I go to D, and then from D, well, I cannot, so where's D? Yeah, I cannot go back to B because B is already visited. So E terminates and returns control to C because C called it, okay? And so there is no other adjacent vertex to E. So C terminates, go back to whoever called it, which is B. There is no adjacent vertex to B other than C, so B also terminates, goes back to whoever called it, which is A. And similarly for A goes back to whoever called it, which is V. Okay, so then V finish iterating over A, so then we go to D, but D has already been visited, so we next visit the next one, which is F. And so from F, I go to here and I label this as visited and add it to the graph from V. Okay, and then I call the algorithm on G. So G is here, so I add it. So from F, we go to G. So what do? We go to G and label this as visited. So from G, I go to D, but I believe we have already visited D. Yep, we have. So we terminate the call and then go to H. And so we have not gone to H yet. So let's label this one as visited and add H here. And then so from H I go to E, but we have already visited E. So the call terminates and H returns. So that H returns, go back to G. G returns, goes back to whoever called it, which is F. F returns to whoever called it, which is V. And so we finish. Okay, so this is the DFS tree. All right, and so next we go to part C. We do that in another video.